In this video, we are going to be talking about Riemann's sums. After understanding the fundamental theorem of calculus, the next thing to understand, which is so important to understanding the concept of calculus, is the Riemann sums. So let's assume that we have a function in the xy plane like this, and this is a function of y of x equal to x squared. We have the left endpoint and then the right endpoint. So let's first use the left endpoint. So what we will do is that we will need to break this integral into small rectangular pieces. So let's assume this is one of the pieces, and then this is the second piece, and this is the third piece. The integral of y of x represents the area under the curve. So let's assume that we are taking the integral from 0 to, let's say, 4. So if this is 0, let's assume this is 1, this is 2, and this is 3 up to 4. Now, what we will do is that we will find the width of the individual rectangles. And we do that by subtracting the lower limit from the upper limit and dividing by the number of rectangles that we have. So in this case, we have 4 rectangles. So it's the upper limit is 4. So that is delta x. Now, the statement of the Riemann's formula says that the area under the curve is giving us sum of I equals 1 to n, then f of x of I times the change delta x, where delta x is the width of the rectangle. So what we'll do is that we need to first find delta x. Now delta x is equal to the upper limit, which is 4, minus the lower limit 0, divided by the number of rectangles 4. So at the end of the day, it becomes 4 divided by 4, which is equal to 1. So delta x is 1. Now, having found delta x as 1, then we need to compute the various areas for the rectangles that we formed. So the first one, f of 0 is 0 because the function is x squared. So a is equal to f of 0 is 0, so I will not do that part. Now let's come to f of 1. So a1 is equal to 1 squared, then times the weight, and the weight is 1. 1 squared is 1, 1 times 1 is 1. Then let's come to a2. a2 is equal to 2, so we'll put 2 in the function. That will be 2 squared times 1, and 2 squared is 4. 4 times 1 is 4. Then a3, you can see that this one to touch the curve, so a3 is equal to 3 squared times 1, and this is equal to 9. So these are the only rectangles that touch the curve. Now the last one, which is a4, does not touch the curve, and therefore we cannot include it. So at the end of the day, the area for the for the left endpoint, so AL, is equal to 1 plus the next one, which is 4, plus 9. And 1 plus 4 is 5. 5 plus 9 is 14. So we are going to get the area here to be 14 squared units. Now let's do same for the right endpoint. So the right endpoint will look like this. So let's assume this is the curve. So for the right endpoint, it will start from here and to go this way. And the next one is going to start from here. And then it will come this way, then to go this way. Then the third one will start from here and to come this way, and then the last one, which is the fourth rectangle. And you can see that in this case, the fourth rectangle touches the curve. Now, this has not been drawn to scale. So we are starting from 0, 1, 2, 3, and then 4. So this is y of x equals x squared. So let's compute the area for the right end point using the Riemann sum. So let's find A0 is 0. So I'll not compute for A0. Let's come to A1. So that will be 1 squared times the width of the rectangle. Now, the f of x is the height of the rectangle, and the delta x is the width of the rectangle. So 1 squared times the width, we already found the width as 1, and this is equal to 1. A2 is equal to 2 squared times 1. 2 squared is 4. 4 times 1 is 4. A3 is equal to 3 squared times 1. And then 3 squared is 9. 9 times 1 is 9. Then A4 is equal to 4 squared. 4 squared is 16 times 1 is still 16. So this is 16. So at the end of the day, if we add all, so AR, which is the area of the right endpoint, is 1 plus 4 plus 9 plus 16. 1 plus 4 plus 9 plus 16 is equal to 30 squared units. So, sorry, the answer is 30 squared units. Then now, in order to find the area that this graph covers, since we found the left endpoint and the right endpoint, we need to find the average. So the area of the graph is the area of the left endpoint plus the area of the right endpoint divided by 2. And this is equal to, the left endpoint was 14 square units plus the right endpoint, which is 30, divided by 2. And this is equal to 44 divided by 2. 44 divided by 2 is 22 square units. So let's find the area by the definite integral and then compare it to the Riemann sum. So by the definite integral, area is equal to integral of the lower limit is 0 and the upper limit is 4, x squared dx. So this is equal to 1 over 3 x cubed, evaluated as 0 and then 4. And then this is equal to 1 over 3, then 4 exponent 3. And this is equal to 21.33 squared units. So you see that doing the Riemann sum using the left endpoint will give you an area which is less than the expected area of 21.33. And then using the right endpoint, you get an area which is above the expected area. In this case, it was 30 square units. But if you find the average that we found was 22 squared units. And the 22 squared unit is close to 21.33 squared units. So the statement of the Riemann sum is integral of a to b of f of x dx is equal to limit as n approaches infinity, the sum as I from I equals 1 to n of f of xi, then delta xi. So this is the statement of the Riemann sum.